Good afternoon, everyone, and welcome to the Open Source AI Summit today. I'm super excited to be talking about the infrastructure for the agentic world. And today I'm going to be talking about why we can't build the future on closed black boxes. And first of all, I would like to give a big thank you to Erica, who has been a wonderful organizer for both the Open Source AI Summit and for BUIDL Europe. And she has been absolutely smashing it, even though she is a new mom. She just had she has a 3-month-old baby right now, and still she is hustling really hard. So I'm super excited to be here. And this is a great place to be talking about what the agentic world is going to be looking like. And my name is Advait, and I'm Chief Strategy Officer at OpenGradient. And my background is a conventional mix of AI and crypto. I started out my journey studying computer science, and then I was a researcher in AI. I published 57 publications in AI across big data, data science, machine learning, and AI. And I got really into the crypto space when I was doing my PhD research at London Business School, where I was looking at wash trading specifically. And the reason I got really excited about crypto was I truly believe in decentralization and actually owning all of my data and owning every part of the process that belongs to me. But that's the reason I ended up getting into crypto. And my first company was called Superside. It was an AI co-pilot for blockchain data. And when I was building this co-pilot, essentially what we were building was a way for you to be able to interact with blockchain data without having to ever code. And the goal here was for you to be able to run agents in the background that make money for you while you sleep. And that's always the ideal goal for every building at the intersection of AI and DeFi. And while we were building this infrastructure, there was one key problem that we faced ourselves, which was that how do you make sure that the models that we are utilizing are not tampered with? So what could happen is I'm selling this infrastructure as an operator for people to manage their assets. And what could be happening is it's just me, maybe not even an AI model that's managing their money. And I'm saying, you know what, I'm going to take all of your money to me. And so in order to prevent this from happening and in order to make sure that the infrastructure that we're using is robust and also the models can be verified, that's where I first encountered OpenGradient. And OpenGradient was building blockchain infrastructure for AI that enables you to be able to run a model verifiably so that you can exactly verify why a model said what it said, and you can generate this proof of execution evidence that I could show to all of my users. And that's how I came on to OpenGradient. And so now let's talk about the agentic world. So what does it mean? Now, I mean, since 2023, there has been so much evolution in AI. We went from chatbots that each person had to interact with to agents that run in the background for you when you're not even at your computer. I was actually just looking through Twitter the other day, and somebody invented a way for Claude Code to call you when its task is done. So you could be running outside, and then you would get a call from Claude Code that, yeah, the next part of your workflow is done. So what do I do now? So essentially, we are moving to a world where agents are going to be doing a lot of work for us in the background, and we don't really have to worry about it. And as Ilya said, what this enables is we can finally move on to bigger problems that we actually care about, and we don't have to spend as much time doing those things that don't matter as much to us. But that's what an agentic world looks like. And in this new world order, it becomes critically important to make sure that the models that you're utilizing, you need to make sure that they run in a trusted way, especially when it comes to critical applications, such as in the healthcare space or in the finance space. Imagine you're interacting with some healthcare agent and it's prescribed you with all of these medications. You need to make sure that firstly, it was a model that said that, and it's the right model. It's not just some random model that a hacker has injected into the background, because these are really critical things like the medicines that we put into our body. And so the infrastructure that we are developing enables you through OpenGradient to be able to verifiably utilize the inferences that are generated by all of these models. And coming to what is OpenGradient and how I think about it. So the way that I see it is we can start from the bottom layer, which is the infrastructure layer. And so what we have built is heterogeneous AI compute infrastructure, where what that means is now you can actually verifiably run inferences on inference nodes, and you can bring data from outside of the blockchain verifiably onto the blockchain so that you can use any kind of data in the smart contracts that you're building. Let me actually define this to you with an example. So let's say that what you're trying to do is you're trying to do some kind of, what you want to do is you want to make an agent that acts on your behalf and makes profit for you on chain, and you're mainly trading volatility. So what you could do is you could run the volatility models on the heterogeneous AI compute architecture in the inference nodes, and then you could securely pull the volatility data, the price feeds, etc., through the data nodes, and you can now execute that in a smart contract that is operating on your behalf. So we also have essentially the execution layer where all of the inference execution is happening into the smart contract itself. Then we have the model hub. So the model hub is a key part, and we'll cover that more deeply here. So the model hub is actually a key part to the infrastructure that we are developing. And so essentially what you could do is you could utilize all of these different models that we have built, and you can see that there's over 1,000 models that are currently hosted on Model Hub. Some of them were built by us, and there are also other developers who came in and built models on top of Model Hub. So you can take any of these models, and then you can utilize those while preparing your smart contracts so that you can have AI inferences natively on-chain. And the goal here, what we are trying to do is we really want to make the developer experience really easy and seamless so that anybody can come in, they can choose the model that they want, and then they can put it into the smart contract so that they can have agents running verifiably on the blockchain in the background at all times. And so here is what I was talking about. The 4 critical aspects about what we have built so far include like the blockchain full nodes, which essentially what they do is they're trying to track state. So this is where all of the blockchain side of the network is happening. And so it tracks the state changes in the AI side of the network. Then the inference nodes, what they do is they compute the inferences, and then they generate a corresponding attestation that the inference was actually run correctly. And there are a few different ways of running the inference. So it really depends on how much security do you need in the application. So let's say that you want it to be like very, very battle tested. And then in that case, what you are better off doing is you're better off running a smaller model and then using ZKML so that you can cryptographically verify that the model ran correctly. And then if you want to run a larger model, what you could do is you could utilize TEs, which are trusted execution environments, so that you can generate a hardware attestation that the large language model actually correctly produced the results. And the next part is the data nodes. So the data nodes enable developers to bring key data. So you could bring data such as market feeds or private data sets, and you can use all of that on-chain. And all of this is integrated with a decentralized file store where all of the models are stored and all of the data is stored. So all of this is easy for you to access on-chain. Now, here is an example which I was talking about. So in this case, what we're trying to do is we're trying to use an AI quant agent to analyze volatility risk of my portfolio assets. So what you could do is essentially you take a volatility model and a spot model that are fed through a token price feed, and then you can utilize these models to accurately calculate what happened to your portfolio over the last couple of days. So the way that this is different from using ChatGPT or Claude or any other AI agent is that here in this workflow, I can make sure that firstly, these are the right models that are being utilized to answer the question that are special purpose for this domain. And secondly, we can verify like exactly why the model said what it said. And the other thing that is really important here is not only are the models verifiable, but the data utilized to feed those models is also stored in data nodes. So here you take the historical price data and then feed it into the Sharp calculator, which is running on the inference node. And so here you can actually verifiably end-to-end, all the way from like taking the data to the model to the result. All of this is verifiable, and you can actually verify it on-chain. Now, let's come to the use cases that all of this technology infrastructure enables. And I'll talk you through 3 different stories. So the first story is about AI that moves money. So when it comes to managing money, so either it be through rebalancing vaults, or it be through like optimizing parameters in your protocol, you need to really make sure that you're using the right models at the right time. And you need to make sure that the models ran exactly how you wanted them to run. You can't risk any deviations from your plans, because like this is managing a lot of money for a protocol. And so in these kind of use cases, you should definitely look into our infrastructure. The second kind of use case, or the second kind of story that I would like to tell you, is about AI that creates reputation systems. So let's talk about decentralized physical infrastructure protocols for a second. So like deep-in networks, like compute networks, what they do is they amalgamate a ton of compute across all of our laptops. And essentially, when you're building like this super powered compute cluster across all of our laptops, what you will have to do is you'll have to make sure that you're giving the tasks that you want to run to the right computers. You don't want to give it to the people who keep failing the tasks. You want to give it to people who have high uptime. And so in this case, what you would do is you would try to put together some kind of a reputation scoring model based on like the uptime of the device and how many times it responded to the request. And so this reputation scoring model, which is a critical piece of this deep-in network, needs to be run verifiably. And so for that, you can utilize the OpenGradient infrastructure as well. And the third kind of use case is AI that interacts with real-world data. So what you can do to build really powerful applications is you can utilize market feeds or sensor data, and you can actually bring like this data on chain using our data nodes, and you can build like applications on top of this. So these are the 3 kind of key use cases that I would look into if I wanted to learn more about verifiability. And let's go deeper into a robotics use case. So I'm just going to walk you through a workflow. So basically now, let's imagine that you have some robots running in the real world, and what they're doing is you have a sensor that is capturing some information, and then you have some perception model that is utilizing the captured information to run some kind of action. So firstly, you have this data that is coming through the data nodes and is fed to this model that is stored on your inference node, and you can actually verifiably plan and propose an action for the robot to run. And then what you could do is you could also have like policy gate check constraints that kind of make sure that the robot is like, for example, it's not like beating people, it's not doing anything that it's not supposed to do. And then it could issue actuation tool calls, and then a receipt would be logged for why the model did exactly what it did. So for example, the way that we envision this being utilized is what you could do is, for example, you have like an on-chain transaction where you have to pay $10 to see a robot dance in the real world. This is an example demo that we're currently working on. But the broader use cases of this is that when you have robots operating in the real world and actually taking different parts of the life cycle of different supply chains, you need to be really sure that the robots are doing exactly what they were meant to do, and there's nobody tampering with the fast food workers to like put the wrong things into your food, or there's nobody kind of like altering the drones that are operating to deliver your food. So essentially, this whole workflow, or all of these workflows, can be verified, and you can actually make it very trustworthy by using the infrastructure that we have developed. And so the ecosystem flywheel that we're trying to build is that, so the more model builders that come into our ecosystem, the more we have developers and applications. And then what that will lead to is essentially node operators that would secure our network more, and that would lead to more tools entering into the system. But yeah, so that was a very brief overview on what OpenGradient is, what are the key use cases, and I'd love to learn more. If anybody has any questions, I'll be around here at the event today, and you can find me at any of these places. And finally, I would also like to thank the Open Source AI Summit team for doing an excellent organization, and that was my talk today.
How do you ensure that node operators are carrying out trusted actions? So, for example, if I'm sending my data to some operator, it's private data, how do I make sure they're not logging it somewhere or something like that?
That's actually a great question. So you mentioned that it's very critical, firstly, that your private data stays private. And secondly, like these node operators, they don't actually see the data that you're sending them, but instead what's happening here is all of these different node operators are running different copies of the model to which like the input gets posted, and it can be as secure as you want it to be. So for example, if you want it partitioned across different nodes, that is also an option. But the goal here is for you to have a seamless workflow where you can actually make sure that the data that you send is private, and if you wanted to keep the model private, that is also an option. So in that case, we make sure that both your data and your model can be private.
Thank you.